When you have a fractional exponent, the numerator is your power and the denominator is your index. So you're basically finding the cubed root of 27. So if you were to write this another way, you would write it with an index of 3. Notice that's in the V. Your 27 is here. And all of this is going to the first power, which doesn't change anything. So basically, you're looking for the cubed root of 27. Well, that means what number times itself 3 times gives you 27. And that's 3 times because that's the index. What number times itself 3 times equals 27? And that would be 3, because 3 times 3 times 3 equals 27. It's a little confusing with a 3 to the third, so 3. That would be your answer that would go in there. And later on we'll do more with that, but that's just a basic. All right, here's another radical. When you add and subtract radicals, you only add and subtract like radicals. You add and subtract the coefficients. It's like if you had 3x and 2x. You can add those together because they both have an x. So you add the 3 and the 2 and get 5x. These are like radicals because they have the same radicand, which is a 2, and the same index. Remember, if the index is not showing, it's understood to be 2 square root. So the 8 root 2, the root 2, and the minus 3 root 2, those root 2's are the same. So all we have to do is subtract the 8 minus 3 and rewrite the root 2. So that would be 5 root 2. Now when you're doing this, you don't have to do all that extra step. That's just so you have that to know where it's coming from. So it's 5 root 2. And make sure, notice it says, simplify the following expressions. All answers must be in radical form. And then I added, this means no decimals. So don't use your calculator. Don't do 5 times the square root of 2 and get a decimal number. They'll count it wrong. They want you to use the radical. Then we're going to rationalize the denominator and simplify or reduce the fraction if needed. Again, do not use a calculator or round to a decimal. Write the exact simplified form. Exact form is with radicals, not with decimal numbers. So one of the rules is we can't have a radical in the denominator. So that's why we're going to rationalize it to get rid of it. And the easiest way to get rid of a monomial radical is to multiply by that same radical. So what I'm going to do here is I'm going to multiply the top and bottom by that radical of root 3. So now the square root of 3 over the square root of 3 is basically 1. Okay, so I'm multiplying the top and bottom by the same thing. I'm multiplying the bottom by the exact same thing because then that will give me a perfect square that I can take the square root of. So when I multiply across, negative 12 times root 3. Now the negative 12 is not underneath the radical, so I just multiply it times that coefficient on that root 3 that's understood to be a 1. So negative 12 times 1 root 3, so that's negative 12 root 3. On the bottom, that's root 3 times root 3, which is the square root of 9. Those are both under the radical, so I multiply the 3 times 3 to get 9. Now you can see if you're multiplying the same radicands and it's a square root, it's just going to come out. You don't have to do that extra step of root 9. So that would be negative 12 root 3. Square root of 9 is 3. Now, we're not finished because we need to reduce this. And you have to be very careful. The 3 on the bottom is not a radical, so you couldn't cancel it with the root 3 on top. Those are two different numbers. The only thing that you could cancel is numbers that are not radicals right here, that coefficient. So that would give us, when we cancel, 3 will go into 3 once. 3 goes into 12 4 times. We still have that negative, so our answer is negative 4 root 3. We have a 1 on the bottom, so we don't need the 1 on the bottom. If we had a 1 on the top, we'd have to have it. But on the bottom, we don't need it. So our answer is -4 root 3. And you can see over here, I left this one. When you hit the key, that gives you the answer. So if you, after you've done it for a while and you're getting the wrong answer, you can press that key and that will show you the right answer. Sometimes it's written weirdly. If you ever have a question about that, just take a picture of it, send it to me, and I'll explain. Also, you can see on here they have videos that will help you, and message your instructor if you need extra help. We are going to be subtracting these numbers. Now, subtraction, this is the key right here. This minus changes all of these signs to the opposite, all of the signs after it, because it's minus means the opposite of. So the -8x, I'm going to rewrite this, -8x to the 5th minus 9x squared minus 6x. And I'm going to change this to a plus 7x to the 5th, a plus 8x squared, and a plus 5, because that negative changes those. And I'm going to just write it underneath. So 7x to the 5th goes right underneath the -8x to the 5th. Plus 8x squared goes right underneath here. And plus 5, that doesn't go right there because that's an x term. So I'm going to move this. And I'm going to put, this is a 0 here. And I'm going to put plus 5 out here because I'm going to do it going this way. So -8x to the 5th plus 7x is -1x to the 5th. When I add and subtract, I don't change the variable and the exponent, it's just the coefficient. -9 plus 8x squared, that would be a -1x squared. -6x plus 0, -6x, because I didn't have an x term in that second set, and then plus 5 on the end. So this is my answer. Now you can write that without the 1. So you could have -x to the 5th minus x squared minus 6x plus 5. That would work also. This is distributive property. We're going to multiply the 5 throughout everything in the parentheses. So 5 times 3x gives us 15x, and 5 times 4 gives us plus 20. So that is 15x plus 20. If you have any questions about these, please email me.